All right, just remember to kind of go over what we talked about last Friday as far as condensing and expanding. Whenever we expand, just like we talked about on number 6, if it is multiplication or it is going to be addition, if it is division, then it is going to be subtraction. So on ones, I don't think you had any like this on Friday, so I want to kind of make sure if you ever have two terms in that bottom side. Okay, so if I have the natural log of 5 over 12x, okay, everything in that bottom side is going to have a negative, and it's really up to you as far as how you want to rewrite this. So if I have the natural log of 5, it's on top, so it's going to be positive. Whenever we go minus, it's completely up to you as far as if I have the natural log of 12x, and you want to separate it out that way, but the problem is these two are getting multiplied. So normally multiplication is going to be addition, which is completely fine depending on, it's really just a matter of how you want to go about this, but just making sure that both of these will end with a negative in front of it. Okay? Nothing's going to change with the natural log of 5 minus, and then if I have the natural log of 12 plus the natural log of x. The big thing here is I don't want to ever end with an exponent, and I don't want to end with parentheses. So whenever I do this, I want to make sure that I distribute that negative to everything inside here. So then whenever I finish, or whenever I'm done with everything, I have the natural log of 5 minus the natural log of 12 minus the natural log of x. Okay. Anything that's on the bottom side of that fraction, anything that's in that denominator spot, should have a negative in front of it, or a subtraction sign in front of it. Okay. I think we did some where we had multiple terms on top and only one on bottom, but now just to be on the safe side, so then you have one where if you have two terms on the bottom side. Okay, then just to kind of reiterate what we did on Friday, remember that whenever we do any of this, that we always want to look to see if there's a number out in front first. So the only one that I need to worry about right now is that 3 and taking 3 to the third power. So then if I have the natural log of 4 plus, what is 3 to the third? Yeah, I'm going to kind of do two steps at once. 27. So I'm going to have 27 minus the natural log of 12. Now, it's completely up to you as far as how much you do or what you want to do, but the 4 and the 27 are going to get multiplied together. Okay, so whenever I have 4 times 27, I'm going to have 108, so I'm going to have the natural log of 108. Since it's a subtraction, I can go ahead and put it all over 12. Divide 108 by 12. Final answer is going to be fully condensed all the way down to the natural log of 9. Now, the last thing before we get into like the modeling and the word problems and stuff like that, the last main part that you're going to deal with is what's called change of base formula. Okay? Change of base is basically a way for you to evaluate or you to get any numerical value of any sort of log. Normally with change of base, it's going to be values that aren't nice and neat. Okay? Like if we had log base 3 of 27, we could rewrite 27 as 3 to the third power and go about it that way. Okay? Where we have bases that are the same and stuff like that. Where it's values that we can find that are in our table and things like that. The problem is there are some values like log base 3 of x, like I could rewrite some values to where I have the base to a power and it's going to give me that value. The problem with doing that is if I have log base 3 of 8, there's no way of me writing 3 to the x power and getting 8 as a numerical value. There is, but do I know that number? Can I multiply 3 by a certain number to get 8? No, because 3 to the first power is 3, 3 to the second power is 9. So it's somewhere between 1 and 2. But it's not going to be a nice number. So since it's not a nice, neat number, then I'm going to have to use what's called change of base. Okay? I can't do it this way. Okay? I can't turn it into an exponential and just go about it and say, hey, it's 2, or it's 5, or whatever it is. It's 1/2. It's a negative 3. Okay, like we could before. So what I've got to do is I've got to rewrite this and I've got to let my calculator do the work for me. So whenever I do this, whenever I use change of base, whatever my of value is, okay, log base c of a, okay, and I can rewrite this as a natural log or as a log. It doesn't matter. Either way is going to work. My of value is always going to be on top. My base value is always going to be on bottom. If you look at the name of the formula, I'm going to change this, of, and then the base. Of is on top, base is on bottom. I'm going to turn this into being, instead of a log base 3, it's going to be in base 10. And all I'm going to do is I'm going to go log of 8 divided by log of 3. I'm going to type it into my graphing calculator, my scientific calculator, whatever I have. And I'm going to go log of 8 divided by log of 3. And I'm going to get 1.82. Okay, what is it? 1.89. Thereabouts. Maybe 3, depending on how many values they want. So what did I do? Well, I went to my calculator, and you can do this really with any sort. If you have a graphing calculator, if you have a scientific calculator. Now, depending on what type of, if you have a graphing calculator, okay, there is probably going to be an easier way of doing this. If you have something like an 84 plus, or if you have the color like I do, okay, the CE, then depending on what mode you're in, okay, where it says either math print or classic, if you have an 83 or like an 84, it's not this version, I don't remember what it's actually called, but if you have like the thin one that's a TI 84 plus CE edition, okay, you have this screen, basically it looks right here, where it either says math print or classic. If you have it in math print, what you can do, yours is even easier than anybody's, is all you have to do is go to math. You can hit the up arrow and it says on letter A, it says log base. Okay, so this is if you have this type of calculator right here or the plus C like this one that's listed. If you don't have a spot where it says math type or math type, then I'll show you the other way here in a second. Or if you have a scientific calculator, I'll show you that way in a second. If you have this version, you're going to type in log base. It's going to give you a spot to put in the base of 3 and the value of 8, or the of value of 8. And all you have to do is hit enter and get 1.8927, so on and so forth. Now, you may not have make sure that you put a parenthesis around this. Okay? You may think that it's just, I don't need to do that. Okay? I'm going to live dangerously. Well, that's not living very smartly. Okay? If that's even a word. I don't think so. That's all right. Make sure that you close the parenthesis if you have to do change of base. If you have a newer 84 or a newer 83, it's probably going to be an 84, you don't have to worry about it. Make sure that if it's in, and you can leave it in classic mode, that's completely all right. Same way as going to work, and I had a student in my 6th hour ask me, he's like, why didn't you tell me we could graph like this? Because I wanted you to make sure you could graph. Same way now, whenever you graph, since we've been doing it this way, if you're not sure as far as what this thing is going to look like, and you have a graphing calculator, you can type in anything, really. I can go log, my of is 2x. And I have a base of 3. It'll graph everything for me now. Same way, if you have this addition and I have it in math print mode, I can do the same thing as everybody else now, just like this, but now if I have math print, you probably could have typed it in and graphed everything and looked at it and said, well, there's 3 and there's 2x. These two values are the same thing. Okay? So now, if you have a graphing calculator, you can graph. So regardless of which one you have, if you have a graphing calculator, you can now graph it to check it. Okay? You're still going to need the other things like the asymptote, the intercept, and all that stuff, the domain and the range. Okay? If you don't have one, you're still just going to have to do it by hand. Okay, but if you have a graphing calculator, either way, if you have a regular like 83 or you have an older version of an 84, then you have to use this route here and go change of base. But if you have the new one, you can put it already in change of base with the math print. Does that make sense? Okay, so now you have all of your options as far as to check your graph and that route. So then when it's going to work the same way if I use the natural log. So if I have log base 6 of 24, but it says use a natural log. It doesn't matter if I use a log or if I use a natural log. I'm still going to go of over my base and still have the natural log of 24 over the natural log of 6. I still have to go to my calculator, and the only thing different here is everybody's got to use the same form. Okay? It's not like I can do log base 6 of 24. If we go here, I can do it really any of the 3 ways. I can have the natural log of 24, closing the parenthesis, and divide it by the natural log of 6, and get 1.7737 and all that. I can do the same thing if I have the log of 24 divided by log of 6. It's going to give me the same answer. In this case, the natural log and the logarithm are the same. They're interchangeable. Okay? And then, again, just like if you have the new fancy version, everything's going to work. Okay? You have 3 different ways, depending on which calculator you have. You have a scientific, then you're going to have to use one of the top 2. If you have an 83, you're going to need to use the top 2. If you have like the newer one like this here, okay, or like the one that's up on the screen, then you have all 3 options. That makes sense? Okay.